In this video, we are going to look at motion of charged particles in an electric field. So let us suppose that we have an electric field which is given by this. And suppose we got 2 points in this electric field. One is point A, other is point B. So if I have a proton which is positively charged and it moves from point A to point B, what will happen to its velocity? What will happen to its velocity when it moves from A to B? And more than velocity, more specifically, or synonymously, we could also say what will happen to its kinetic energy. Right? Or for example, we got an electron which moves from point A to B. Again, what will happen to its velocity or kinetic energy? Now, in this kind of questions, we need to be really careful to see whether we need to be really careful to see or to estimate or to see the direction of force on the charged particle here. Now, if you look at this electric field, it won't intuitively give you direction of force on a proton if proton is here. So the trick is to always assume that there is a positive charge on this side at the tail of your electric field arrows. Now everything will be very clear because these charges are this plate is positively charged here, and electron or proton is at point A, and when it goes to point B, basically it is being repelled by the positive plate because like charges repel. So proton is positively charged, this plate is positively charged, so this proton here will feel a force of repulsion, so it will run away from A to B, and it will run so that its velocity would increase. So when the proton goes there, proton goes from A to B, its k goes up, k increases. So now the question arises is that proton's kinetic energy has increased. Where has that increase in k come from? All right, so we can talk about where did increase in k come from? Energy can neither be created nor be destroyed. So only way this kinetic energy, this particle's kinetic energy increases is if some sort of potential energy is lost. We know that energy cannot be created, so we can say that gain in k, it has to be equal to loss of p. Likewise, let's look at the electron here now. An electron goes from point A to B. So electron instead of proton here, I got an electron now, and this electron is moving from A to B. Now this electron is being attracted, it's feeling a force of attraction towards this positive plate here. So when it moves from A to B, it slows down. So here that means electron will slow down because the positive plate is holding it back. Positive plate is attracting it in the positive direction. So it will slow down, which means that k will be lost. So this loss of k, where would it go? I mean, we can say here that loss in k will be equal to gain in p. All right. Now we can generalize this thing, but just want you to look at these. I got 3 statements here, and we need to fill the blanks here. So first one is positive charges. Positive charges, we need to write here either loss or gain, and here also we need to write loss or gain. So what is happening here? Positive charge is loses or gains P, and loses or gains and gains or loses K when they move in the direction of electric field. So just we saw here, I mean, this is the electric field here. I'm just drawing it here again so that we can see this statements on the same screen here. So this is my electric field, and when a positive charge move in the direction of electric field, what is happening to it? So again, the trick is to assume that there is a positive charge here and there's a negative charge here, and when the positive charge is moving in the direction of electric field, we will see that it will speed up, which means its kinetic energy will increase. So it will gain kinetic energy, which also means that it will lose potential energy. Likewise, if we got a negative charge here, and if the negative charge move against the direction of electric field, so negative charge is moving in this direction. So what is happening? This is a negative charge electron here. When it moves in this direction from here to here, it is feeling attracted towards the positive plate, so it will speed up, which means there will be gain in K, which also means that there will be loss of P. The third one I want you to write on your own. Now, so far we have discussed that there would be either loss of P or the gain of P. Now we are going to talk about the value or the quantum value of this gain or loss. So, all right, that is a sentence here. When an electric charge Q moves in an electric field, then the change in P, also known as delta PE, will be equals to Q delta V, where delta V is equals to potential difference also called as voltage difference between 2 points connecting the path. Between 2 points, no, cannot connect 2 points. Between 2 points on the ends of path. So the language hasn't come out really well, but I think it will become clear when we look at this example. So I just go to the same example here. This is my electric field here, and these are the 2 points, point A and point B. The voltage of the potential of point A is equals to VA, and likewise potential of point B is equals to VB. And here in this particular case, we also know that VA is greater than VB, because electric field is always from high voltage to the low voltage. So if a positive charge now moves from here, positive Q here, then we know that there will be gain in K and there will be loss in P. I mean, as we've already discussed above here. So we know the gain. We know whether there will be gain of P or loss of P, but the value of that P, gain of P or loss of P, will be equals to Q delta V, and Q is this, and delta V is VA minus VB. So one simple example, we can probably look at it. Suppose I have these values here. VA is equals to 400 volt and VB is equals to 200 volt. Then delta V is equals to VA minus VB, and that equals to 400 minus 200, which is equals to 200 volt. So the voltage difference, the potential difference between point A and point B is equals to 200 volt. And now I can find out the change in P and K of different charged particles. So for example, suppose electron moving from A to B. Now we know that when electron moves from A to B, because again I would suggest use the trick of putting don't need to actually draw this here, but you can put in your head. When you look at this diagram, you can assume that there is a positive plate here. You can visualize that there is a positive plate here. So when electron moves from A to B, it will slow down. So it means there will be a loss of K, and that also means there will be gain of P, and this will be equals to electron's charge Q times delta V is equals to Q is equals to 200 volt. Sorry, Q is equals to 1.6 times 10 to the minus 19. That's the charge of electron, and delta V is equals to 200. So that will give you 3.2 times 10 to the minus 17 joule. So electron, when it moves from A to B, it will lose this much K, and the same energy will appear as a gain in its P. Yeah, and likewise we can look at other particles as well. For example, if you got a proton here moving from A to B, then again, as you already seen in the previous screen, that when the proton moves from A to B, it will feel a repulsion and it will speed up. So there will be gain in K, and that will be equals to loss in P, and that will be equals to again Q delta V. Because charge is same, so the value that we finally end up with is 3.2 10 minus 10 to the power minus 17 joule.